Factoring to solve quadratic equations. So standard form of a quadratic equation is ax squared plus bx plus c, where a, b, and c are real numbers and a cannot be 0. And the reason a can't be 0 is if we multiplied by 0 times the squared term, we would no longer have a quadratic. So when we talk about standard form of a quadratic, we're talking about descending order equal to 0. So like a degree of 2, degree of 1, degree of 0, and equal to 0. Descending order equal to 0 would be standard form of a quadratic equation. So let's turn each of these quadratics into standard form. To get them in descending order equal to 0, I also like to have a positive a value for standard form. So p squared plus 81 equals 18p. I want to get this 18p to the other side. Subtracting 18p from the left side and the right side, I get p squared minus 18p plus 81 equals 0. On this one, to put in standard form to get in descending order equal to 0, I want to subtract 9x to get it to the left side and add 18 to get x squared minus 9x plus 18 equals 0. To get this one in descending order equal to 0, subtract 25 from each side, and I'm now in descending order equal to 0. Zero factor property. So if a and b are real numbers and a times b equals 0, then what do we know about a and b? If I multiply two numbers and get 0, then I know either a had to be 0 or b had to be 0. So the whole reason we factor is to turn these addition signs into multiplication so that we can use this fact, the fact that if I multiply two numbers and get 0, one of them had to be 0. This is what allows us to solve quadratic equations by factoring. That's the whole point of turning things into multiplication, is that a times b equals 0, then either a had to be 0 or b had to be 0. This allows us to solve. So for example, if I factored a problem and I came up with x plus 2 times 2x minus 1 equals 0, I know that either this equals 0 or this equals 0. In order to multiply two numbers and get 0, one of those two things is true. So I can use that to solve by setting up each part that has a variable equal to 0. So I'm going to make some little equations. By the zero factor property, we know that the product is equal to 0, then one of the factors must be 0. So I want to take this first set of parentheses, x plus 2, set it up equal to 0, and then I'm going to take the second set of parentheses, 2x minus 1, and set it up equal to 0. So that's where our two answers are going to come from. So I have these little equations to solve. X plus 2 equals 0, subtract 2 from each side. I have x of negative 2. And this equation, 2x minus 1 equals 0, add 1 to each side, divide both sides by 2, and I get x is 1/2. So my two possible solutions, and I'm going to write that in set notation, is negative 2, comma, 1/2 are my two possible solutions. All right, so let's say we've solved and we've factored and we have these two binomials. We have x minus 5 times x plus 2 equals 0. To solve my quadratic, I'm going to set up each part that has a parenthesis. I'm going to set up equal to 0. So I'm going to do x minus 5 equals 0 or x plus 2 equals 0. Solve my equation. I add 5 to each side. On this equation, I subtract 2 from each side. So my two possible solutions, x is negative 2 or 5. Is my solution set. All right, so let's say we have factored and we have the two factors of x times 5x plus 3. Now to solve, I'm going to take each part that has a variable and set it up equal to 0. So I get this really hard equation. Oh, I get x equals 0. It's kind of already pre-solved, the easiest of all equations. And then the 5x plus 3, I also want to set that part up with a variable equal to 0. Subtract 3 from each side, divide by 5, and my solutions are negative 3/5 and 0. So once I'm in factored form, I'm just taking each part that has a variable, setting it up equal to 0, and solving. Taking each part that has a variable, setting it up equal to 0, and solving to get my solution set. And my solution set I just put in braces and list my possible answers. So we can write down these steps. Solving a quadratic equation by factoring. Step 1, write the equation in standard form. Get that equation in descending order equal to 0. Step 2, factor completely. And that tends to be the hardest step, is to make sure you know all your rules for factoring to factor completely. Step 3 is to use the zero factor property. Set each factor with a variable equal to 0. And step 4 is to solve each equation produced in step 3. So this is what a typical problem would look like for solving quadratic equations by factoring. First thing we want to do is get this in descending order equal to 0. Since I have a positive a value here, I'd go ahead and move the 9x to the other side by subtracting 9x and add 18 to each side to get x squared minus 9x plus 18 equals 0. Then I want to look to factor. Well, I don't see a GCF. I don't have a perfect square trinomial. 18 is not a perfect square. But if I'm looking for two numbers that multiply to 18 and have a sum of -9, I come up with -3 times -6 has a product of 18. But if I add -6 and -3, I get -9. So this is what I would call traditional factoring, numbers that multiply to 18 and add up to -9. Now that I'm factored, I can take each of these factors and set them up equal to 0. I can do x minus 6 equals 0, or even in my head, what would make this 0 if x were 6? Or I could set this equation up as well, x minus 3 equal to 0, add 3 to each side, and I get my two solutions of 6 and 3. All right, you guys pause the video here. Make sure you follow all 4 steps. Put it in descending order, factor completely, and solve each of the equations from the previous step. Pause the video here and come back and we'll check. All right, welcome back. So this one to factor, well, it's already in descending order, which is great. Step 1 is done. Step 2 to factor, I am looking at a GCF of x. If I pull a GCF of x out, I get x times x minus 7. This binomial, I'm checking to make sure there's no GCF or no difference of squares to make sure it's factored completely, and x minus 7 does not have either of those. Now to solve, I'm going to take each part that has a variable, set it up equal to 0, so I'm going to do x equals 0, x minus 7 equals 0, so add 7 to each side, x is 7, so my solutions are 0 and 7. Hopefully you guys got that. Number of solutions. The degree of a polynomial is equal to the number of solutions. So let's say I have a degree of 3. That's going to tell me I get 3 solutions. Now, sometimes this is misleading. I can get up to 3 solutions. Occasionally, you'll have an answer repeat where you won't end up with 3 unique solutions, but a degree of 3, we should expect to get 3 solutions. So let's say we've solved a quadratic equation. We've factored a quadratic equation to get x times x plus 1 times x minus 3 equals 0. Take each part that has a variable, set it up equal to 0. So I could do x equals 0, x plus 1 equals 0, x minus 3 equals 0. Solve my 3 different equations. And I get a solution set of 0, -1, and 3. So my degree in this case equaled my number of solutions. All right, guys, pause the video here. Try to solve each of these 4 quadratic equations. All right, welcome back. Number 1, x squared minus 25. To factor that, it's already in descending order equal to 0, which is nice. To factor, I have difference of squares. I have x plus 5, x minus 5. And then if I set this up equal to 0, x will be 5. If I set this part up equal to 0, x will be -5. So my solution set, 5 and -5. Next one is in descending order equal to 0 already that I'm looking to factor. I'm looking for, this one looks no GCF, not a perfect square trinomial. I'm looking for numbers that multiply to -8 and add up to +7. So I could factor that as x plus 8 times x minus 1. They multiply to -8, add up to +7. So the value that would make this equal 0 is if x were -8, and the value that would make this 0 is if x were 1. Next set, I have a perfect square trinomial, but if you didn't catch that, you could also do traditional factoring. X minus 6 times x minus 6 will give you the same answer. And then what value would make this equal to 0? If I set up two small equations, x minus 6 equals 0, x minus 6 equals 0, I get 6 twice. So this one, even though the degree was 2, we expected to get 2 answers. We actually got the same answer twice. So we could have, we're just going to list 6 one time. We don't need to list it there twice. So the solution would be 6. Next one is already in descending order equal to 0. How do I factor that? Well, binomials, I'm looking for 2 things. I'm looking for GCF, and I'm looking for difference of squares. 8 is not a perfect square. I can pull a GCF of C out, though. So C times C minus 8. Then set up each part equal to 0. Set C up equal to 0, so C is 0. C minus 8 equal to 0, so C would be 8. So hopefully that helps you guys get started in solving quadratics by factoring. Have a great day.